Hello guys, welcome back to my channel Algorithm Minds. My name is Hassan Khurram and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach Tableau, a data visualization tool. So for today's tutorial, I'm going to teach you how you can actually generate a two-dimensional convolution of two matrices with the help of this function conv2. So basically it's quite simple to interpret. Hello guys, welcome back to my channel Algorithm Minds. My name is Hassan Khurram and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach Tableau or data visualization tools. So for today's tutorial, I'm going to teach you how you can actually calculate two-dimensional convolution of matrices A and B with the help of this function called conv2. So this is the notation how you can actually call the function in MATLAB. So first of all, you will declare a variable, then put equal to sign, then call the function conv2 and the pass two input argument, which is actually the matrices. So it will return the two-dimensional convolution of matrices A and B. If A is a matrix and B is a row vector, then C is a convolution of each row of matrix with the vector. If A is a matrix and B is a column vector, then C is the convolution of each column of matrix with the vector. That being said, first of all, we are going to generate two matrices, okay? And first one we are calling function rand and passing one input argument, which is 3. So 3 in case will actually generate a matrix of 3 by 3 order that has values that are randomly generated between the value of 0 and 1. So we have initialized a variable named A for matrix A and we have initialized a variable named B for matrix B. Now in order to calculate the convolutional, first of all we are initializing a variable C full, then equal to sign, then we are writing conv2 function and passing two input arguments A and B. So let me just run this block of code for you. So now you can see that we have a full convolutional of two-dimensional convolution of matrix A and B. So there is an additional input argument we can pass to it beside the matrix A and B, which is called shape. So what it does, actually it returns a subsection of convolution according to the shape. For example, let's say we have C variable and equal to sign conv2, A, B same. Returns the central part of convolution, which is the same size as A. So here you know that A is a size of 3 by 3 column, 3 rows and 3 column. Now we are passing 3 input argument to the function conv2. The first input argument A and B and the last input argument is actually same in the form of string that is passed as an input argument. Here now it calculates the center part of convolution, which is the same size as of A. Okay. Now there is another thing which we can actually do here. We can define another input argument. For example, conv2 uva. Such convolves with each column of A with vector u, then it convolves with each row of a result with vector v. This behavior applies regardless of whether u or v is a row or column vector. So let us go and extract 2D pedestrian edges. The Sobel edge finding operation uses a 2D convolution to detect edges in image and other 2D data. So for example, you are dealing with the image data set and you want to actually calculate the convolution. So there is a method called Sobel edge finding operation which uses a 2D convolution to detect edges. So how we can actually do that? First of all, let's create an empty matrix that has 10 rows and 10 columns. And how we can do that? We will call function zeros and pass only single input argument like 10. So here 10 identifies that we would like to have 10 rows and 10 columns. Now that being said, what we actually are doing, we are actually with the help of matrix indexing. Now you can see that we are indexing the rows of 3rd row to 7th row, and we are also indexing the 3rd row to 7th column, and we are setting its value equal to 1. So this here ones is as function in MATLAB that generates a matrix of n order. Here n order means like n rows and n columns. So in our case it's 5 rows and 5 columns. Now once we done that, what we can actually do, we can actually call mesh function of MATLAB and visualize that matrix with the help of mesh plot. So simply just write mesh and within the input argument we pass A. Now this is the plot. Now you can see that the value like third row to the seventh row has a value of 1. Apart from that, every elsewhere we have 0 values. Now convolve the row of A with the vector U, then convolve the row of resultant with the vector V. The convolution extracts the horizontal edges of the pedestal. So we have, first of all, we will like to define U and V vector. So we have like 1, 0, -1 and V vector 1, 2, 1. So once we define that, what we are going to do, we are going to create the convolution. So of U, V and A. So I will call the function conv2 and I will pass 3 input argument U, V and A. A in our case is this matrix. Now I would like to again generate the mesh plot of the two-dimensional convolution value. So this is what it actually looks like. Okay, in the same way we can change the value to extract the vertical edges of pedestrian, reverse the order of convolution with U and V. Okay, so now we are reversing the order. So we have conv2 function and V first input matrix, the U is the second input matrix and A is the actual shape of the matrix, and then we are using mesh CV to actually see the plot in the form of mesh of the matrix CV. And finally we can further play around with generate our own function, which is basically just an element wise operation on the both generated convolutional 2D convolutional. So here it's the mesh of that plot. Also, I hope this tutorial have been helpful to you. If you have any issues or any question regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. Thank you for joining me, and